Good morning and welcome back. I just wanted to let you know that this morning and this afternoon we're going to be taking some notes to recap all the things that we learned last week in math. So at the top of your paper in your jam, go ahead and title this Notes, Multiplication, Recap. And so know that the note examples that we put in our notes today are going to help us with the worksheet that we're going to be solving later in the class period. So what I'd like you to do is go ahead and just kind of divide your paper into 4 boxes. And on the left-hand side of your paper, we're going to call this the just side, the joining equal sets side. On the other side, we're going to call this part of a whole set. These are the two actions, if you remember back to last week, that we talked about with fractions. So my intent here is to review joining equal sets, and then we'll review part of a whole set. Then we'll set up our paper for completion on the worksheet. So please make sure that you're taking good notes. The expectation is that if I'm writing it, you're writing it in your notes also. So when we're talking about joining equal sets, we're talking about groups times each, and that will give us our total. So if you'll write that out, that'd be great. And the next thing that we're going to write out is our problem. 2 times 5/6. And so what that means when we break this down is 2 groups of 5/6 each. So if I wanted to solve this, not only can I do the math part, but I should be able to use a picture to get my example. So I'm going to start with my picture first. So I'm going to start by drawing my 2 groups. This is group 1, and this is group 2, because I have 2 groups. What I need to do next is I need to partition each picture into 6 equal parts and shade 5 of the 6 parts. So the easiest way to do that is to first partition it into 3 equal parts and then divide it in half. So now I have 6 equal pieces. Again, partition it into 3 equal parts and then cut that in half so that I have 6 equal pieces. The next thing that I want to do is I want to shade 5/6 of each model. So I'm going to shade in 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember, I can use my picture to help me get the answer. So knowing that each model was cut into 6 equal pieces, my denominator is 6. And then I can just count how many 6 I have. So I have 5, 6, 7, 8, 9, 10, 6. Now when I see that, I know that this is an improper fraction, so I have to think about how many wholes I can get. So I could just move one of these pieces over here. That will make this 1 whole with 4 of the 6 left. And again, I should recognize that 4 is even and so is 6. So both of those numbers can be cut in half to make a new fraction name called 1 and 2/3, because I can use my friendly number 1 to divide by 2 on the top and to divide by 2 on the bottom to get that new fraction name. Now, we do want to recognize that the algorithm is taking our number 2 and without changing the value, putting it over the number 1 and multiplying numerator times numerator to get 10. and denominator times denominator to get 6, which is exactly the same thing. So that makes me feel good about my answer. And knowing that 10 divided by 6 will give me 1 whole with 4 out of 6 pieces left over. And again, understanding that 4, 6, 4 is even and 2 is even, there is another name out there. I can rename this by dividing the numerators by and the denominator by 2 and getting that answer 1 2/3. So I definitely want to box that in. Let's try another example for our notes. This time we're going to do 4 times 4/7. It's kind of a strange fraction, kind of an awkward number to work with. But what that really means is that we have 4 groups with 4/7 each shaded. So what I want to do is start by drawing 4 boxes. So I have 1, 2, 3, 4. My denominator tells me how many equal pieces, so I'm going to cut this into 7 equal pieces. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Now I'm going to go back and I'm going to shade in 4 of the 7 pieces. So we have 4, 4, 4, and 4. So I have 4/7 4 times, which is exactly what I want. So now I have 4, 8, 12, 16 sevenths shaded. Now when I look at this fraction, I know that it is improper. So what I want to do is I want to rename it. And I'm thinking to myself that I know that how many groups of 7 are in 16? So 7, 14, 21. So there's only 2 groups, and that would give me 14. Well, 16 is from minus 14 is going to give me 2 leftovers out of 7. So my rename is 2 2/7. Now if I go back over here and I do the algorithm, I should get the same thing. So I'm going to put a number 1 over the number 4 so that I can multiply numerator times numerator, denominator times denominator. So that's going to give me 4 times 4, which is 16, and 1 times 7, which is 7. It's the same answer I got here. And now I can divide 16 divided by 7 is going to give me 2 wholes. That would give me 14, and 16 minus 14 is 2 left over out of 7 equal pieces. So again, my answers are matching, and they should be. Alright, so that was a recap of joining equal sets. The next thing that we're going to put in our notes would be the information about part of a whole set. So we're going to practice that too. So the first fraction that we want to put in our notes is, or the first equation that we want to put in our notes is 2/3 times 9. So remember, when we see 2/3, that's the part of the whole set of 9. So the first thing that I want to do is I want to draw 9, but I want to put them in 3 equal groups. So the easiest way to do that is to just kind of partition 3 areas, and we're going to be counting to 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I'm going to go back and label this 1/3 of the group, 2/3 of the group, 3/3 of the group. And I need to shade in 2 of the 2/3 of the 9. So I'm going to shade in all of these and all of these. So when I count them, that's 3, 4, 5, 6. That's 6 of the 9 pieces. Now if I were to go back and do the algorithm, again, I'm going to put a number 1 over the number 9, and I'm going to multiply numerator times numerator to get 18, and denominator times denominator to get 3. And if I divide 18 divided by 3, I will end up getting 6, which is the same exact answer that I got here. So that's making me feel really good about things. Let's try another one. This time, let's try 3/4 times 12. So what does that mean when I'm solving? That means that I have 3/4 part of a whole set of 12. So I use my denominator, and I want to think about 4 groups, and I want to draw 12 items. So again, I'm going to partition my paper into four columns, and I'm going to start counting to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Now I'm going to go back underneath, and I'm going to label this as 1/4 of the group, 2/4 of the group, 3/4 of the group, and 4/4 of the group. And I want all 3/4 of the group of 12. So I want all of these circles, all of the 2/4 group, and all of the 3/4 group. That will give me 3, 6, 9 of the 12 pieces. So 9 is my answer. Or I can go back and I can solve the algorithm, which is 3 groups of 12, which would give me 36, and 1 times 4, which would give me 4, and 36 divided by 4 is going to give me the answer 9. All right. So hopefully using these examples will help you with our practice that we're going to be doing next. So I'll see you back for the picture perfect practice in the next video.